Hey everyone, this is Tommy signing on Energy Academy. And today I'm going to be talking about why your energy costs a lot more. Now, there's something that is a known phenomenon as technology improves. We notice that the cost of things get less expensive over time. So, for example, the first computer was about the size of a room and it was very expensive and very difficult to build. But as time went on, we learned how to make things more efficiently, how to make things smaller, and the cost of our computers got smaller and smaller as time went on. In fact, everyone now has computers in their hands and in their pockets. We call it smartphones. And so what we notice is that as we get better with the technology, as we understand how to manipulate the physics of things, we essentially can produce that same thing cheaper and more efficiently. But that's not what we're seeing with energy costs. We see energy costs rising. Energy costs has risen so much in the last years, especially in advanced nations. People are seeing energy costs and it is really biting them in their pockets. And so in this video, I'm going to be explaining why energy costs has gone up quite substantially. Now, when this topic gets brought up, people always say, no, that's not true. Energy costs hasn't gone up. In fact, they say the cost of things like solar and wind has gone down over time. So which is it? Has energy costs gone up or have they gone down? Well, that really depends on what you're defining as energy costs. The cost to consumers, that is the end users of energy, has gone up considerably. However, it is true that the cost of things like wind and solar has gone down. As you can see on this chart, the levelized cost of electricity or the levelized cost of energy has gone down for things like solar and wind power generation. So what is really going on here? Why is there a drop in the cost of the energy assets like wind and solar, whilst at the same time end users and customers are paying more for the energy? For this video, I'm going to be using the UK as my case study, and I've selected the UK because it's a fairly typical wealthy advanced nation in terms of the amount of energy it uses and in terms of the amount of so-called green energy that it uses. And the reason I say so-called green energy is because I don't believe there is such a thing as green energy by the dictionary's definition of it. I explained this in my last video, and if you want to find out why I don't believe there is such a thing as green energy, I'd encourage you to go and check it. For us to understand the issue at hand, you have to understand that there are two types of costs. There is the cost to the investors for investing in an energy asset, and then there is a cost to the end users. Those two costs are not the same thing. And this is where people get confused, why sometimes people say the cost of energy has gone down, like the cost of solar panels and the cost of wind turbines has gone down. That is true, but that's only the cost that the investors are paying or have to make to essentially procure that energy assets. And so if you think about it, before a gas plant gets built or before a coal power station gets built, someone has to invest in it. That could be a private equity, or that could be a merger between a government and a private entity. But what you have is some type of investor that needs to put money down to invest in that asset, and they only do that based on an analysis of if that asset or that investment is going to be profitable for them. And so this cost of investment is what you call the LCOE. That is completely different from the cost that the customer has to pay when they switch on the light or when they turn on their gas cooker to make some food. That's a different cost. You need to keep that in mind. The LCOE cost, which is the cost the investor needs to put down to invest in an energy asset, and then there is the end user cost, that is the energy user cost. Two separate costs, but those two costs are traveling in two different directions. The cost of the end user is going up while the cost of the investor is going down. And I'm going to explain why in a bit. So the LCOE takes into account two main things. It takes into account the cost of operating that energy asset throughout its lifetime. And it also takes into account the amount of energy that will be generated from that energy asset over the same lifetime. So the LCOE basically looks at the cost of running that asset over its lifetime divided by the amount of energy that asset is going to provide. Now, the devil really is in the detail, because the LCOE on the face value doesn't actually tell you why the cost of the end user is going up or why the cost to the investors is going down. But we need to dig a bit deeper, because within the LCOE are different costs that are factored. So you have cost of running the energy assets, the cost of the fuel that you will need for the energy assets, say things like taxes, say things like debts you need to repay on the energy asset, right? These things are fairly general and fairly standard for different types of energy assets. However, there is something that is quite unique, and that is the cost of carbon. Now, LCOE essentially takes into account the cost of carbon. Now, it is assumed that CO2 is essentially going to destroy the world if we keep producing more of it. And so a penalty is put on energy assets that produce CO2. So a gas power station or a coal power station or a combined heat and power station produces CO2. Therefore, there is a penalty that is put on those energy assets, and that is factored into the LCOE. So if you have an energy asset that essentially produces CO2, there is more cost that will come out of that energy asset than an energy asset, say for example, wind or solar, that doesn't produce CO2 at the point of generation. And so this disparity essentially is what has made wind and solar energy cheaper and more attractive over time compared to coal power station or gas power station. So I take some information from the IEA, which is the International Energy Agency, and what I did basically was look at the raw data that was given by the IEA and run the IEA calculator. And what the IEA calculator shows that after nuclear and gas, you have wind and solar as the third and fourth best energy assets to invest in from an LCOE point of view. However, when you remove the cost of carbon from the calculator, right, when you take away that cost, which I believe is an artificial cost, what you find is that the cost of wind and solar remains the same. However, the cost of things like coal power stations or lignite or combined heat and power becomes cheaper. So just based on the cost of carbon alone, you are finding that wind and solar are not as attractive a source of energy. So that's one of the big reasons why over the years we see energy cost has gone down quite substantially, because of this artificial carbon cost or carbon tax that is placed on the energy assets. Now, it's my argument that the LCOE value actually is a very skewed value, and it actually causes a lot of distortion to the energy market and has a lot of negative impact, and is not actually reflective of the true cost of the energy assets. Let us assume and let us accept that CO2 is bad for the environment. I have my disagreement with that logic. I have my disagreement with those that think like that, but let's say that is the case, that CO2 is actually bad for the environment, right? And so we place a penalty on CO2. In the same way, we have to place a penalty on wind and solar assets, because for us to get wind and solar assets, we need to mine the earth and destroy large sections of the Earth's ecosystem in terms of the use of rare earth mining. We have to use a lot of coal to make the concrete, to make the steel, to make the glass for solar panels or for wind turbines. We need to use a lot of coal for this. We don't actually take that into account in the LCOE value, right? There's also the issue of the fact that we don't actually know what to do with large parts of wind and solar farms because they are very unrecyclable. So for example, the material the wind blades are made from are fiberglass, plastic resin polymers, and essentially these are impossible to recycle and essentially buried. That's the only way we resolve this issue. And also you have solar panels which have a lot of materials within it that make them very difficult to recycle because of the high level of toxicity of the materials contained within the solar panels. So we assume that wind and solar are these sort of perfect, clean, pristine sources of energy, when in reality they are high earth burden sources of energy. High earth burden sources of energy. There is a lot of environmental cost to this sources of energy like wind and solar that is not actually factored into the LCOE. Yet we actually factor in the environmental cost of coal, oil, and gas in the LCOE. So you're not comparing apples and apples, you're essentially comparing apples and bananas. Now, this takes me to what I believe is the worst effect of wind and solar energy on our electric system, and that is that wind and solar are essentially parasitic form of energy. What I mean by this is that the more wind and solar you add to your electricity grid, the more expensive that electricity grid becomes. If you have reliable energy supply and demand, that means you will have stable energy costs over a long period of time. In fact, you can actually have decreases in the cost depending on how well efficiencies are achieved on the supplier or on the end user end. Energy prices can be reliable and stable for a long period of time. But if you introduce things like wind and solar at the levels that we've seen over the past 20 years, especially in the UK and countries like the UK, you introduce a lot of the instability that wind and solar brings into energy systems, because the wind doesn't always blow, the sun doesn't always shine, and they are just not reliable, and there is nothing anybody can do about that. That technology is an inferior technology because the weather does what the weather wants to do. We have no control over it, so you're always going to have massive fluctuations from week to week, from month to month, from year to year. But the sad irony is, when we actually have to start backing up wind and solar because of their massive fluctuations with coal and gas and oil, we have to pay a premium not just for using the gas and oil on short notice, but we also have to pay the carbon tax. So we're paying twice. We're paying the premium because of wind and solar's unreliability, but we're also paying the carbon tax. This double whammy is why over time energy prices have been nudging upwards, and it's squeezing people who do not have enough money and who are struggling at the bottom of the economic food chain. And I think this is not right. In fact, this is one of the things that has driven me to create this channel, because I'm a firm believer in everybody having access to reliable, clean, safe energy. But at the same time, I think there is something quite perverse with having investors being able to make away like bandits with investing in so-called green energy, which aren't actually green, and at the same time having the end users pay a lot more. Something is not right there. So that's what this video is all about, helping you to understand why as our energy price at the end user level gone up while the cost of investing in that energy has gone down over time. So I hope this video was helpful for you. And the next video I'm going to be talking about solutions, because that's what I'm all about. I'm an engineer by training. I'm an engineer in my thinking and in my philosophy. And I'm all about solution. And we're going to be talking about how can we make our energy markets work better? How can we make it more efficient? How can we actually unlock it to make the end users pay less? I've got ideas that we can implement tomorrow. If you enjoy the content I'm putting out, I'll say you should like it and you should subscribe to my channels. I'm on YouTube, BitChute, Rumble. Thank you for listening. This is Tommy signing off on Energy Academy. Bye-bye.